आपका पहला सुपर टीचर कौन था?
आई,
मबो,
मम्मी,
ताई,
माँ,
माई,
मोजी,
माझी आवे, मॉम।
इस मदर्स डे अपने पहले सुपर टीचर की शान बढ़ाओ और सरकारी नौकरी घर लाओ। जी हाँ, टेस्टबुक सुपर कोचिंग लाया है एक अमेजिंग ऑफर जहां आपको मिल रहा है 20% का एक्स्ट्रा डिस्काउंट और 33% की एक्स्ट्रा वैलिडिटी सिर्फ और सिर्फ इस 13, 14 और 15 मई को। इतना ही नहीं, अब आप जीत सकते हैं एक स्मार्टफोन सुपर कोचिंग की तरफ से और दे सकते हैं अपनी माँ को एक तोहफा। तो अगर आप स्क्रीन पे दिए गए एग्जाम्स की तैयारी कर रहे हैं, तुरंत जाइए और टेस्टबुक सुपर कोचिंग में एनरोल करिए। देश की सभी माँओं को मदर्स डे की हार्दिक शुभकामनाएं।
Hi, good evening, everyone. This is Shefali Singla, and in this session, we are going to cover the concept of normalization. So already we have covered the basics of RDBMS. We learned the concept of finding the keys, prime attributes, non-prime attributes, and in Saturday's session, we have also covered the concept of decomposition, in which we had look over how to identify whether the decomposition is lossy or lossless, or its dependency preserving or not. Very good evening, Shubham. If those concepts are clear, then obviously there will not be any problem while solving the questions related to normalization. It's very, very easy and obviously very, very important topic. So, guys, quickly tell me that anyone having any doubt in the basics of RDBMS, or especially अगर मैं पूछूं कि कैंडिडेट कीज फाइंड करने में प्राइम एट्रीब्यूट, नॉन प्राइम एट्रीब्यूट एंड in the concept of decomposition, anyone having any issue or any problem? If it's clear, then without wasting our time, we'll start from the different normal forms and the categories of different normal forms. It's clear. All right. So, first of all, the purpose of normalization is to reduce the redundancy or to eliminate the redundancy which is present at different places. So, कौन सी place पे available है, that is identified by various normal forms. Okay. So, here, first of all, what we need to do is we need to identify that where the redundancy is available, and if it's there, then we have to remove it by decomposing the relation into the sub relations. Okay. So database normalization is the process of organizing the attributes of the database. जितने भी attributes है इस तरीके से organize करने such that the redundancy will be eliminated or reduced. Having the same redundancy is nothing but when we are storing the same data at different places again and again. So definitely that is going to create the anomalies as well. So the purpose is to reduce or eliminate it. Because of data redundancy, what problems can occur? Problems like if we are storing the similar data again and again, so obviously it requires more space. It may result into inconsistency, because if we are going to update, insert or delete the data at one place, then uh, the same changes has to be done everywhere. If there is only one or two places where you have made the changes and others are unchanged, then definitely there will be a problem of inconsistency. So these are the two major problems which occurs because of data redundancy. So that is, first problem is it increases the size of the database, problem number one, and second one is inconsistency problems occur due to insertion, deletion and updation operations. This is the second problem. Okay, so problems are clear. So now we need the solution is to apply different normal forms. So normalization is a process of minimizing the redundancy from a relation or set of relations. Minimize कर रहे, reduce कर रहे, and it may help to reduce the redundancy, and normal forms are used to eliminate it. So quickly tell me that what all normal forms are there for normalization. How many normal forms are there? Or in another words, if I ask that what are the different normal forms? I have already told you earlier as well, those who are studying the subject DBMS in their semester. So this is one of the important and the lengthy question. It might be asked in 5 or 8 marks, like what is normalization and explain the different types of normal forms. Okay, so this complete session will give you the clear understanding for the same. But जो competitive exams है, there you will be given with the relation and the functional dependency set, and you might be asked that what will be the highest normal form that is satisfied by the given relation, like that. Okay. So how many normal forms are there? Anyone having any idea that how many normal forms are there? So in total, there are 6 normal forms known as 1NF, first normal form, 2NF, second normal form, third normal form, BCNF, boys code normal form, 4NF, and 5NF, fifth normal form. So here, these normal forms are categorized into 2 categories. First set is still BCNF, and next one is 4NF. So these are known as these first 4 normal forms are based on single valued dependency, and 4NF and 5NF are based on, very good Akshay, based on multi-valued dependency. So actually what will happen if we are not given with the data, or in real life, can somebody tell me that up to which normal form the normalization will be applied? Practically, when we are going to implement the database, then up to which normal form these normal forms are applied? Because of single value dependency, we can also call this as schema based normal forms, and these are data based. I guess this is the biggest hint that I can give you. Now you can tell me the answer that up to which normal form the normalization is applied in the practical implementation of DBMS. Anyone? See, when we are going to design the database, then at the initial stage, we do not have any kind of data available. So definitely we will be only following up to schema based dependency. Database के लिए we need some data to apply the normal forms, and initially during the implementation phase we do not have any data. So up to BCNF, highest normal form that is applied is the BCNF. So in BCNF, there is 0% redundancy. There is 0% redundancy because of single valued dependency. Okay, so there is 0% redundancy. This is the highest normal form under this category, and up to this normal form it is applied. Moreover, there is one more point. 3NF is the most accurate and the highest normal form. Schema loaded, it's schema based. Yeah. So BCNF में हमारे पास problem क्या होती है? Sometimes when we are converting the database, we are taking the database to the BCNF form, then it is not preserving the dependencies. Okay, like अगर BCNF की condition satisfy नहीं कर रहा, then we need to decompose the database. तो जब decomposition होती है, दो properties satisfy करवानी है. One is lossless joint decomposition and dependency preserving. But BCNF ensures only lossless joint decomposition but not dependency preserving decomposition. So that is why BCNF is not the accurate normal form. If the accuracy is required, dependency preservation is important to the database, then in that case we'll normalize the database only up to 3NF. But agar koi ek dependency lost ho bhi jati है and that lost dependency is not playing any significant role or it is not affecting the database much, then in that case we'll go till BCNF. But the highest and the most accurate normal form is 3NF. Is this clear? तो जो क्वेश्चंस आते हैं, क्योंकि अगर प्रैक्टिकल इम्प्लीमेंटेशन देखते हैं तो प्रैक्टिकली दीज नॉर्मल फॉर्म्स आर इम्प्लीमेंटेड, सो जनरली द क्वेश्चंस आर बेस्ड ऑन द बेसिस ऑफ 1NF 2NF 3NF and Boyce Codd normal form. This is Boyce Codd normal form. Okay, so let's start with first normal form. First normal form simply says that there should not be any multi-valued attribute. Presence of multi-valued attribute is not allowed in the database. Now what is this multi-valued attribute? नाम से समझ में आ रहा है जहाँ पे एक attribute के लिए multiple values हो सकती है. For example, if you have enrolled yourself for some training program, one student might have enrolled for more than one course. So in that case, the student ID remains the same, name of the student remains the same, but not the course ID. So let us assume that there is a relation student, and in this relation, I'm considering only three attributes: SID, SName, and course name. Let us assume that there is some roll number 1 and the name is John and it has enrolled for the course C and C++. Okay, दो courses में enroll किए. There is student 2, Mary, and it has enrolled for the course C++ and Python. There is third student. Two students can have the same name in a same batch. So John, and it has enrolled for the course Python only. So if you observe here for this relation, can you tell me that what will be the primary key of this relation? Or the key for this relation is student ID, because we know that no two students can have the same roll number, no two students can have the same SID, two students can have the same name, or in one course multiple students can be enrolled. So एक ही option बचते हैं हमारे पास key के लिए, that is the student ID. Okay, but now if you observe this relation here, course name is the multi-valued attribute, because for one attribute multiple values are coming up. So this is not allowed in 1NF. In a relation contain if a relation contain composite or multi-valued attribute, it violates the first normal form, or a relation in the first normal form, it does not contain any multi-valued attribute. तो इस केस में क्या करेंगे? We need to take the separate entries. So let's create a table here. This is not in 1NF because of the presence of multi-valued attribute. So here we'll be taking SID, SName, and course name. Now we have said that roll number 1, name is John, and it has enrolled for the course C. This has also enrolled for the course C++. This is the roll number, SID is 1, name is John. Yes. Next, SID is 2, name is Mary. It has enrolled for the course C++ and Python. Next is student ID 3, name is John, and it has enrolled for the course Python. Right? So now here in this case there is no multi-valued attribute. यहाँ पे किसी भी attribute के अंदर multiple values नहीं आ रही हैं, so there is no multi-valued attribute. So on the basis of this, we can say that this relation is in 1NF. But here, have you observed? I guess everything is going behind the image. Wait. So this relation is in 1NF. Now it is in 1NF. But have you observed one thing? It has increased. हमने ये बोला है कि normalization हम use कर रहे हैं to reduce the redundancy, but here it has increased the redundancy. Student ID, student name is same, and for that we are getting the name as the course name as C and C++. Yes, make sense? तो यहाँ पे क्या हुआ? This has increased the redundancy. This has increased the redundancy, but still we are performing 1NF because it is going to behave as the base for the other higher normal forms. क्योंकि जब हम 2NF की बात करते हैं तो second normal form is based on 1NF. Second normal form says that the a relation should be in 1NF and there should not be any partial dependency. Okay, so here SID S name is determining the course name, but here if we identify the candidate only on the cases or only on the basis of SID, we cannot uniquely determine the tuple. Repeated entries are there. S name cannot be the key. Course name cannot be the key for this relation. That means in this case we will be getting a composite key. Now here what will be that composite key? SID S name मिलकर uniquely course name को determine कर रहे हैं, नहीं कर रहे, right? So here we can say that the key for this relation is SID course name. This is the key and it is determining the student name. So here ID is, this is the dependency. So candidate key for this relation is SID and course name. Make sense? Is it clear? So this is about the first normal form. Nothing much is there. The only thing is no multi-valued attribute is allowed. So we have to eliminate it. Guys, this is our official Telegram group, that is Shefali ma'am Testbook. ये मैं इसलिए आपको बता रही हूँ so that those who are following this session for the first time, guys, please don't focus on noting down the things, because anyhow I'll be sharing the PDF of all the YouTube sessions in this Telegram group, that is Shefali ma'am Testbook. You can join this Telegram group and the link is given in the description box. Just go there and join it. Apart from that, if you have any doubt or query or any suggestions, then you can post that in the Telegram group. Apart from this, you can directly interact with me. You can participate in the quiz and the polls. Okay. So this is about the first normal form. Drawback is it increases. Drawback with first normal form is it increases redundancy. Rahul is saying please share this telegram link. Rahul, एक बार जो आप वीडियो देख रहे हो ना यूट्यूब वाली, इसके डिस्क्रिप्शन में जाओ एंड आई गेस दैट्स द फोर्थ लिंक. आगे लिखा हुआ है सुपर कोचिंग टेलीग्राम. सो जस्ट click that link and it will take you to the telegram group. एक बार चेक करके मुझे बताओ, have you got that? Otherwise, once we are done with the concept, I'll share my screen and I'll show you that where is that link present in the description of the video. Okay. Any other query? So next one is the second normal form. Very important, because usually the students get confused in the definition of partial dependency. So please focus on this. This says that if a relation has to be in second normal form, the very first condition is it should be in 1NF. That means there should not be any multi-valued attribute. And second condition is, first one is it should be in relation R should be in 1NF, and there should not be, or in simple terms we can say that, no partial dependency. These are the two conditions. No partial dependency. So these are the two conditions for second normal form. Now the whole concept is based on partial dependency. Anyone having any idea that what is this partial dependency? So all the points that I'm discussing, it's already written, and you'll get that in the Telegram too. So to be in second normal form, a relation must be in first normal form, and relation must not contain any partial dependency. कोई भी partial dependency नहीं होनी चाहिए. अब ये partial dependency होती क्या है? I'm sorry, I forgot to add here the extra slides. Anyways, what is this partial dependency? Partial means some part of. Some part of what? Some part of key. That means proper subset of key, proper subset of key, if it is determining non-prime attribute. What is this non-prime attribute? That is a non-key attribute. We have already discussed that how to find out prime attributes and non-prime attributes. So if a proper subset of key is determining a non-prime attribute, then we say that this is partial dependency. That means partial dependency, and it is not allowed in 2NF. Okay, or in other words, we can say that if X is a composite candidate key means एक attributes, एक से ज़्यादा attributes से बनी है candidate key. If X is a composite candidate key and Y is a proper subset of X, Y is a proper subset of X, okay, and some A is non-prime attribute. Okay, wait a minute. I guess whatever I'm writing, that's going behind the image. So let me help you out with that. Hope now it's visible. Right? So Y is a non-prime attribute. Y is a non-prime attribute. तो इसको हम कैसे देख सकते हैं? Let's say this is X, and Y is a proper subset of X. ओके और x अगर कैंडिडेट की है तो x के अंदर जितने भी एट्रीब्यूट्स होंगे all those attributes will be the prime attributes, but if a is a non-prime attribute, that means it is lying somewhere outside the circle, white circle, right? So a is somewhere here. If y is determining a, this is known as partial dependency. Partial dependency, and this is not allowed in 2NF. So this is partial dependency. So here I have written the definition for partial dependency. This is saying that no non-prime attribute, कोई भी non-prime attribute. Non-prime attribute means that is not a part of any candidate key, is dependent on the proper subset of candidate key of the table. यानी कि कोई भी non-prime attribute किसी भी proper subset of key पे dependent नहीं हो सकता. That is partial dependency. In simple terms, we can say that apart from this rule, everything else is required in 2NF. If we have something like non-key is determining prime attribute or non-prime attribute, both will be allowed. Non-key hai. Key is determining prime attribute or non-prime attribute, that is also allowed. Only thing that is not allowed is okay, if proper subset is determining proper subset of key is determining prime attribute, that is in fact allowed. So all these are the cases which are allowed. The only thing that is not allowed is proper subset of a key determining non-prime attribute. ये clear हुआ? सिर्फ एक ही केस अलाउड नहीं है, that is proper subset of key determining non-prime attribute. Make sense? Is it clear, people? So this is 2NF. Next one is third normal form. Third normal form says that a relation should be in 2NF. 2NF में होगा. First condition is R should be in 2NF, and apart from that, what is the condition? In this case, there is no transitive dependency allowed. And no transitive dependency के लिए आपको बहुत ज्यादा डेप्थ में जाने की जरूरत नहीं है. And I'm so sorry. And no transitive dependency. Okay, so here what we need to do is simply we'll check if there is any dependency given x determines y. So x should either be a key or y should be a prime attribute. So if either of the condition is true, then we will say that that dependency is in 3NF. And that is the condition about the third normal form. So a relation is in third normal form. This is the definition that we'll be using for our questions. A relation is in third normal form if at least one of the following condition holds in every non-trivial functional dependency. Clear? What is that dependency? So here we are given with x determines y. So x should be a super key or y should be a prime attribute for the dependency. Okay. Next one is voice chord normal form. This is the highest normal form because of the single value dependencies. So in voice chord normal form, it simply says that on the left hand side there should always be the prime. There should, on the left hand side, it should always be a key. I hope now image is back because now on the slide we have sufficient space. So a relation R is in BCNF if R is in third normal form, and for every functional dependency, left hand side should be a super key. That is, if we have the dependency like x determines y, so this x should always be a super key. So this is the more stricter form than 3NF, but still in all the database implementations, practically BCNF is not the highest normal form. It depends on the criteria and the requirements of the database. Agar accuracy chahiye, no loss of dependency should be there, then in that case we have to go till 3NF. Okay. So this is about the basics of the normal forms and different types of normal forms. अब question किस type के आ सकते हैं? Competitive exam में theory point of view से आपको I hope समझ में आ गया होगा. Anyone having any doubt? Because I'm going to take the questions next. Is this clear, guys? So there are few key points, important points on the basis of which you can expect the true false questions or 1 mark questions. So first of all, BCNF is the highest normal form, so it is free from the redundancy. if a relation is in BCNF, अगर कोई भी relation BCNF में है तो definitely वो 3NF में भी होगा. अगर 3NF में है तो surely it will be in 2NF also and 1NF. If a relation is in 2NF, so definitely it must be in 1NF as well. So if a relation is in BCNF, then 3NF is also satisfied. Next point, if all attributes of a relation are the prime attributes, अगर सारे के सारे attributes prime attributes हैं तो highest normal form कौन सी होगी? BCNF में we are saying that there is, in BCNF we are saying that on the left hand side there should be a key, but 3NF में हमने क्या बोला, या तो लेफ्ट हैंड साइड पे की हो या फिर राइट हैंड साइड पे प्राइम एट्रीब्यूट हो. So if all the attributes are prime attributes, so that means second condition will always be satisfied. So we can say that if there is any relation which is having all the prime attributes, then that relation will always be in 3NF. You need not to check for this point. So this statement is also true. A relation in our DBMS is always at least in first normal form. Our DBMS हमेशा कम से कम first normal form में होगा ही होगा. Next one, every relation, every binary relation. Binary relation means a relation in which there are maximum two, there are exactly two attributes. Let us assume that there is a relation R with the attributes AB. अब यहाँ पे कोई ना कोई dependency तो exist करेगी. If case one, if the dependency A determines B exists, then we can say that the candidate key is A. If B, this is case 2. If we are saying that B determines A exists, then the candidate key will be B. If we are saying that A determines B and B determines A, both exist, B determines A, both exist for this relation, then the candidate key will be, we will be getting here two candidate keys A and B. तो यहाँ पे क्या होगा, अब चेक करो what will be the highest normal form for this. On the left hand side we are getting the key, on the left hand side we are getting the key, on the left hand side we are getting the key. This means that every time we are getting a super key on the left hand side, if a relation is a binary relation, so we can say that every binary relation will surely be in Boy's quad normal form, that is BCNF. So every binary relation, a relation with two attributes, is always in BCNF. Clear? Next, a relation has only singleton candidate key. Singleton candidate key means candidate key is composed of only single attribute, one attribute only. Then in that case, the relation will be in. अगर एक ही attribute है, prime attributes कितने, non-prime attributes कितने, we have no idea about that. And we are even not sure about the number of candidate keys. Singleton candidate key से हम एक चीज sure कर सकते हैं, there will be no proper subset of a candidate key. This means that there is no possibility of getting no proper subset of candidate की. अगर proper subset नहीं है candidate की का तो partial dependency का कोई case ही नहीं बन सकता, right? So this means that if a relation is having only the singleton candidate keys, then the relation will surely be in 2NF because there will be no partial dependency possible in that case. Next one, sometimes when we are going for the BCNF, it may or may not preserve functional dependency. I have discussed this point in the beginning of the session that BCNF does not takes the guarantee that when you are going to decompose the relation, it will be in, it will preserve all the dependencies. Okay, so BCNF, in that case, we will go for, so practically BCNF कब implement करते हैं, if the lost functional dependency is not required, otherwise will be following the normal forms till 3NF only. This is how it is implemented practically. Next, there are many more normal forms like 4NF, 5NF and so on, but those are the database dependencies. So in real world, database systems does not require beyond BCNF. Okay, so that's why we are covering till BCNF in this session. So this is the overview of the normal forms and the key points. Anyone having any doubt? Otherwise, we'll be solving the questions. Guys, quickly give me the confirmation if there is no doubt. Hurry up. Because after this, we'll quickly keep on solving the questions. No confirmation. Okay, chalo koi baat nahi. Let's solve the questions. It will give you more clarity. This is saying that we are given with the relation R, A, B, C, D, and we are given with the functional dependency set, and we have to determine the highest normal form. जब आपसे highest normal form पे question पूछा जाए तो what we'll do is we'll start from BCNF. But we have observed that the concept of normalization is based on the candidate keys, prime attributes, and non-prime attributes. So the very first step is to find out, to determine the candidate keys. In this relation, what will be the candidate key? Let us find out AB closer. AB closer will be A, B, C, D. And if you observe here, it is containing two attributes. तो मैंने आपको बोला है कि directly आपको minimal super key इसे नहीं बोलना है, since it is determining all the attributes of a relation. So surely it's a super key, but is it a minimal super key? We are not sure about it. So for that, we will take the subset of the key attributes and will find if its proper subset is determining all the attributes of a relation or not. So it's not determining. So we can say that AB is one of the candidate key. Next is, since A is present on the right hand side of D, so that means BD will also be behaving as the candidate key. So BD, D is determining A, AB is determining C. So BD is another candidate key. अब और कोई attribute right hand side पे present नहीं है. D was present on right hand side of AB. We have already covered that. So on the basis of this, we are getting three attributes as the prime attribute, that is A, B, D, and non-prime attributes are C only. Okay. So we have got the prime attributes and the non-prime attributes. Now let's find out the highest normal form. Dependencies given are AB determining CD. This is D determines A. And first of all, we'll check for BCNF. BCNF says that on the left hand side, it must be a super key. AB is a super key. Yes, AB is a super key. So this is allowed in BCNF. D is a super key. No, this is a proper subset of a key. So not allowed. Next. 3NF. 3NF जो भी dependency BCNF में वो 3NF में होगी. Problem was coming here. तो left hand side पे we are not getting a super key, but on right hand side are we getting a prime attribute? यही बोला था हमने 3NF में कि या तो left hand side पे key हो या फिर right hand side पे prime attribute हो. So here we are getting a prime attribute. So we can say that this dependency is allowed in 3NF. So the highest normal form is 3NF. This relation is in 3NF. This is one type of question that can be asked in the exam. You will be given with a relation, you will be given with a set of functional dependencies, and they'll ask you to find out the highest normal form. Clear? Second type of question, although abhi tak aaya nahi hai, but this can be asked in the numerical answer type. Okay, you might not be given with the options. They'll say that identify the number of relations if the relation is in BCNF. अगर relation को BCNF तक लेके जाना है, then how many relations will be there? That means we have to check for the conditions for each and every normal form. If it is not satisfied, then definitely we have to go for the decomposition. Correct? So how to proceed with this type of question, since this is the first question? So let me try it for you. Relation R is given, functional dependency set is given. जब भी normalization का concept है तो सबसे पहले candidate keys find कर लो. So for this relation, the candidate keys are, can somebody write in the chat section that what are the candidate keys, prime attributes and non-prime attributes for this relation? A is determining B, C, D, E, F. So A is one of the candidate key. Next one is A is present on the right hand side of B and C. So BC will be the another candidate key. B and C. So I guess that's it. Yeah. There is no other possibility of getting the candidate key. Prime attributes will be A, B, C, and normal non-prime attributes are D, E, and F. Okay. Now here we have to identify the relations. If the relation is in BC and F, कहाँ से start करेंगे? From 1 and F. So whenever we are given with our DBMS, the relation will at least be in 1 and F. So this is already in 1 and F. तो conditions कहाँ से check करनी शुरू करेंगे? From 2 and F. Check करो, is this dependency allowed in 2 and F? Yes, this is allowed in 2 and F. I'm looking for 2 and F. Because this is a key, it's not a proper subset of key. BC is a key, so it is also allowed in 2NF. B is a proper subset of key. If you take this dependency, B is a proper subset of key and F is a non-prime attribute. So what is this? This is nothing but partial dependency, and we know that in 2NF, partial dependency is not allowed. This is partial dependency and it is not allowed in 2NF. So what we need to do is we need to decompose this relation. Next one is D determines E. D and E. D is not a proper subset of key. ये proper subset नहीं है. So this is also allowed in 2NF. The only dependency that is not allowed in 2NF is B determines F. तो जब भी कोई भी dependency problem create करती है, then what we need to do is we'll keep that in a separate table or we will decompose the relation. और decomposition कैसे होती है? जो भी problem create कर रहा है, decomposition of a relation is just like decomposition of a group, dividing the group. Group कब divide होता है? When there are two set of people, one are saying one point और दूसरे ग्रुप के लोग कुछ और बोल रहे हैं. जैसे दो फ्रेंड्स का ग्रुप है, कहीं पे जाना है, कुछ लोग बोल रहे हैं मूवी देखने जाना है, कुछ लोग बोल रहे हैं कि हमें शॉपिंग के लिए जाना है. तो अगर ज्यादा लोग हैं, like approximately 50-60% are saying we have to go for a movie, तो एक ग्रुप मूवी के लिए चला जाएगा, बाकी लोग जिनको शॉपिंग के लिए जाना है they'll go for shopping. So basically the group is divided. Similarly here, B determines F is not satisfying the definition of 2 and F. So we'll keep the attributes of this dependency. जो भी rule को disobey कर रहे, जो भी rule को violate कर रहे, will take that to the separate group. Okay. So here we were given with the relation R. This is A, B, C, D, E, F. So problem किसने create की? B determines F. So on the basis of this, the decomposition of relation is taking place. R1 and R2. Problem create की B determines F. Attributes are BF. So it will be decomposed in one relation. Another one is remaining attributes. जो बाकी के attributes है वो दूसरे relation में बचेंगे. A, C, D, E, F. Is it a correct decomposition? Decomposition के लिए हमने दो properties discuss किए. It should be lossless join. Lossless join means पहली condition में हमने क्या किया था? Join करने के बाद, union लेने के बाद, all the attributes should be covered. यहाँ पे सारे attributes cover हो रहे हैं. A, C, D, F is already covered, so F will not be taken. Okay. All the attributes are covered. A, B, C, D, E and F. सारे attributes सारे intersection लेने के बाद हमने बोला था join करवाने के लिए there should be some common attribute. Are we taking here any common attribute? No, no common attribute is there. So we need to take here the common attribute. Common attribute कौन सा लेंगे? It should be the key attribute. तभी आपके पास lossless join decomposition आएगी. ये कौन से steps बोल रही हूँ मैं? These all are the steps which we have followed for lossless joint decomposition, right? So here, this relation is decomposed because of the dependency B determines F. So on the basis of this, we can say that the candidate key for this relation is, अगर B closer find करते, it is covering all the attributes of R2. So B is the key for this relation. And the common attribute should be the key attribute, है ना, तभी आपके पास lossless joint decomposition आएगा. So this is the decomposition. ये point clear हुआ? I guess when earlier I was discussing this concept in the NIC batch, for them the concept of decomposition was not over, so that's why people were struggling with this concept. तो ये चीज clear हुई. The relation R, which was having 6 attributes, is decomposed into 2 sub-relations, R1 and R2. R1 is having the attributes A, B, C, D, E, and R2 is having the attributes B and F. Okay, now check for this is lossless joint decomposition. Dependency preserving भी देखना है. यहाँ पे देखो कौन कौन सी dependencies आ रही हैं. A determines B, C, D, E is preserved here. तो यहाँ से आपके पास एक dependency बची, that is A determines F. We have to check that. B, C determines A, D, E. This is preserved here. B, C determines F. This we need to check. Next one is B determines F. This is preserved. D determines E is preserved here. F is present in only the relation R2. So A is determining B. ये कहाँ से आएगी आपके पास? A determines B. This is present in R1. And B is determining F. This is present in R2. So transitively this dependency is preserved. Right? So this is also preserved. Next is BC determines F. BC will be determining B and B is determining F. So this dependency is also preserved indirectly. So that means all the dependencies are preserved. Can you tell me that what will be the key for this relation? What is the key for this relation? A is determining B, C, D, E. So A is one of the candidate key. A is present on the right hand side of BC. So BC will be the candidate key. That's it. So we have got the candidate keys and functional dependencies. So by this time we are saying that now this is in 2NF. Also this is lossless decomposition and it's dependency preserving as well. Dependency preserving as well. यहाँ तक clear हुआ? Now we have to go till BCNF. So second normal form के बाद we have to go to third normal form. I'm using green ink for a third normal form. Now let's check for 3NF. अब आपके पास सिर्फ यही दो relations है. Is this dependency is in 3NF? B is a key. 3NF में हमने बोला लेफ्ट हैंड साइड पे की हो या फिर राइट हैंड साइड पे प्राइम एट्रीब्यूट. सो दिस इज अलाउड इन 3NF. सो नो डिकम्पोजिशन इज रिक्वायर्ड हियर. R2 में कोई डिकम्पोजिशन नहीं होगी. चेक हियर, दिस इज अ की अलाउड इन 3NF. BC is a candidate key, so this is also allowed in 3NF. D is ना तो ये की है और ना ही ये प्राइम एट्रीब्यूट है, so this is not allowed in 3NF. तो 3NF के रूल को disobey किया, so it will be decomposed. Relation was we had R2 here, B and F were the attributes, and R1 was having the attributes A, B, C, D, E, and now we need to decompose it further. किसकी वजह से decomposition हो रही है? Because of DE. So I'll be taking this as, let's call this as R12. DE is creating a problem. R11. Remaining attributes are A, B, C. A, B, C. These are the remaining attributes, but this is decomposed because of D determines E. So we need to find out its candidate key. Candidate key is D here. So include it in this relation. Is it clear? Now we have done the decomposition. उसके बाद आप check करोगे lossless है क्योंकि common attribute is the key attribute. So this is lossless decomposition. Now we have to check for dependency preservation. This B determines F is also in 3NF. This is in 3NF as well as in BCNF. because this is a key. Now this is a key, so it is in BCNF. ये BCNF में भी है. So R1, 2 and R2 are in BCNF. जो भी dependencies आएंगे यहाँ पे, here we have the dependency B determines F. जो बाकी की dependencies बची हैं, take those dependencies. So here we have where are the dependencies? Okay, so A determines B, C, D. A determines B, C, D will be preserved here. E is not present. So we need to check A determines E later on. Then next we have BC determines A, D is preserved here. BC determines E. We need to check D determines E is preserved here. Now check here, A determines, this will be preserved as A determines D is present in R11 and D determines E is present in R12. So this dependency is preserved. Basically what I'm doing is, according to the definition, we are finding that which dependency is following the rule of that particular normal form. अगर dependency rule को follow कर रही है, then it's fine. If it is not following the rule, then we have to decompose the relation. Decomposition के लिए हमारे पास दो points हैं. One is lossless. Lossless के points थे, all the attributes should be covered. There should be some common attribute क्योंकि join करवाना है, and that common attribute should be the key attribute. I had taken the example where I have explained that if you are going to take the non-key attribute as the common attribute, then the decomposition will not be lossless. Okay, so whatever is the key for the other relation, we are taking that attribute as the common attribute. BC is determining D, it is preserved here, and D determines E is preserved here. So BC determines E will also be preserved. Since all the dependencies are preserved, so on the basis of this, we can say that here we have the candidate keys. I guess again, image is creating a problem. बच्चे जब कोई problem होती है, please write that in the chat section because sometimes it's not visible for me. Okay, so here we have this relation, and these are the, we are writing here. Hope it's visible now. So R11, R12 and R22. So this is the dependency. For this case, candidate key is B. For this case, candidate key is D. For this one, here we are getting the candidate keys as A and BC. Now check for BCNF. For BCNF, A is a key allowed in BCNF. C is a key allowed in BCNF. D is a key allowed in BCNF. B is a key allowed in BCNF. So we can say that now this relation is in BCNF, as well as there is no dependency lost. This is lossless decomposition. Plus this is dependency preserving. Clear? Guys, is it clear? So ultimately we had to identify the number of relations. कितने relations बने? Here the relation R was given A, B, C, D, E, F, and this is decomposed into R11 having the attributes A, B, C, D, R12 having the attributes D, E, and R2 having the attributes B, F. But here we were supposed to return only the number of relations, so the answer for this question is 3. Is it clear? So this is another type of question. I'm giving you one question as the assignment, and today we'll be having a master class as well. Okay, so in the master class we will discuss the solution. So this is the question similar to the previous one. This is for your practice. At 8 p.m. we will be having a master class. So during in that class, I'll be discussing the solution for this question. You have it's going to be approximately 5. You have 3 hours, so please revise the concepts of normalization, solve the practice questions that I'm giving you right now, and after that try to go through the previous year gate questions. अगर नहीं भी कर पा रहे हो कोई बात नहीं, just focus on the concept, revise the concepts that we have covered, and at 8 p.m. we will have the session on PYQs on the basis of normalization. This is for your assignment, just give it a try. Okay, यहाँ पे भी आपको number of relations identify करने, if the relation is in BCNF, just like this. हो जाएगा? And this is based on identifying the highest normal form. So can you tell me that what will be the highest normal form here? Or let me give you these questions as the assignment. So these are the questions. Immediately I'll be sharing this PDF in your group. Okay, so just download that PDF and solve all these questions, and we'll have the discussion over these questions in another 3 hours. Okay, so guys, those who are new, you can join the Telegram group Shefali ma'am Testbook. इसी group में मैं अभी ये PDF share करने वाली हूँ. In fact, on daily basis, I'm sharing the PDF of all the YouTube sessions in this group. Doubts and discussion will also be there in the group. जो भी आपके doubts आप post कर सकते हो. You can directly interact with me. Quiz or polls. We soon will start with the quiz and the polls, and you can participate in that. In the next session, we will be having the discussion over the ER model. Okay. So that will be the agenda for tomorrow's session. So let me discuss the schedule with you guys first. So daily from Monday to Friday, we are having 2 sessions, one at 4 p.m. and other one is at 8 p.m. This 4 p.m. session is on YouTube. This is a YouTube session, and this is the free master class. YouTube तो free होता ही होता है, so that means both the sessions are free, and in the YouTube agenda is कि जितने भी concepts है वो हम YouTube पे cover करेंगे और related questions will be solved in the masters class. तो 4 to 5 session होते हैं, बीच में आपको 3 hours का time मिल जाएगा. Immediately आप revise करो और उसके बाद questions करो and your topic will be done. I hope this seems to be a good idea, right? अगर हम चीजों को ऐसे करते हैं कल डिस्कशन करेंगे परसों करेंगे वो फिर पेंडिंग हो जाते, सो लेट्स नॉट कीप एनीथिंग पेंडिंग. नाउ दोज हु आर फेसिंग अ प्रॉब्लम इन जॉइनिंग द टेलीग्राम ग्रुप, लेट मी शेयर माय स्क्रीन. Just give me a minute. So currently this video is going on. What you have to do is go to the description box. This is the first link for the master classes of NIC batch. And this is the link. Second link is to join the NIC Super Coaching. Basically, Super Coaching is where you get the recorded sessions, live sessions, theory, uh, and practice set questions, mock test, and previous year papers. So everything is available in the Super Coaching. You need not to buy the test book pass exclusively. It's already included. And similarly, we have the Super Coaching Telegram link. So बच्चे गेट सुपर कोचिंग का ये टेलीग्राम लिंक है, you can join this link. And if you are interested in covering the whole syllabus for the GATE, you are dedicatedly preparing for GATE or you are focusing on the other PSUs as well. So my suggestion is at least prepare for the GATE exam because majority of the syllabus will be the GATE syllabus and काफी questions previous year GATE questions होते हैं. So doesn't matter for which exam you guys are preparing, but don't forget to solve previous year GATE questions. Okay. So here you have multiple options, like you can view all the courses. I'm going to the full course, बाकी आप देख सकते हो. So full courses provided by the GATE forum and full courses provided by the Digimento, full courses provided by the Nimbus. That is NEEF batch is going on, and apart from that, complete courses there by me and my team. So you can see the ratings of all the batches, and 4.9 is, I guess, it's really good to maintain this rating because it's not about hundreds of students, those who are following this session, it's thousands of students, those who are following this session. Okay, so yeah, and if you want to take the super coaching, then we have three plans for you. One is the 3-year plan, 2-year plan, and 1-year plan. So you can see that 3-year plan is for 26,999, 2-year plan is for 21,094, and 1-year plan is for 13,499. To get the extra benefits, just use here the code Shefali S. This is also given in the description box. So code is Shefali S. SHEFALIS. Okay. I hope यहाँ तक कोई प्रॉब्लम नहीं है. लिंक सारे मिल गए, तो जितने भी लिंक्स हैं यू कैन फॉलो ऑल द लिंक्स हियर. इनफैक्ट दोज हु आर प्रिपेयरिंग फॉर एनआईसी, तो एनआईसी के मैंने प्रीवियस ईयर क्वेश्चंस करवाए थे ईयर बाय ईयर एंड subject by subject, so you can follow that playlist here. Its link is also given in the description box. जब आराम से बैठ के आप देखोगे ना, you will get lot many links, so just go through it. So guys, anyone having any doubt? I hope that this is clear. So this is all from my side. I'll see you in another 3 hours in the masterclass. If you have any doubt or query, please write that in the chat section. Otherwise, we'll end this. And अगर आपको लगता है कि अभी कोई डाउट नहीं है, बाद में हो सकता है, तो आप मास्टर क्लास में भी पूछ सकते हैं. That is also a live session. Okay. All right. I guess there is no query. So let's end our discussion here. Thank you so much, guys. I'll see you at 8 p.m. Please be on time, and do revise the concepts of normalization before joining the masterclass. Thank you. Bye bye. God bless you.